Okay, so next lesson that we've got in regard to networks and graphs is we're looking at further directed networks and graphs, and we're looking at critical path analysis with backward scanning. So for more complex problems, it's necessary to record more information on the network diagram. Okay. To complete critical path analysis, we use a process called backward scanning. And look, effectively, it's not rocket science, but we're going to start at the end and we're going to work our way towards the front, as opposed to the previous scanning that we've done with the little houses where we've gone forward. Okay. When two or more paths follow the same node, we take the smallest difference, and the result of it, of all this, sort of reveals the start and finish times, and the earliest and latest start times that a project could still continue without being delayed. It'll make more sense when we discuss it. So the latest finish time of an activity is the latest start time of the next activity, and that sort of makes sense. If it's going to take 7 minutes for something to happen, and then the next task has got to start, well, it's got to start at 7 minutes, if that makes sense. So the float time is the amount of delay that could be in a project. We'll go through to an example, and we'll use this formula. As the process goes on, but there's a copy of this as well. So let's just jump straight into example, and this will actually make a little bit more sense. So what we've got here is we've got a directed network graph, okay? And what I've got here is the activities A, B, C, and D, and the number afterwards is the amount of time that activity takes, okay? So this is not too dissimilar to what we've done previously, okay? And if we then move forward, and again, we've done some of these before, I might just do the forward scanning. So what that means is that I'll put a 0 up there in the roof of the house. How long will A take? Well, it'll take 12. How long will C take? It'll take 16, 12 plus 4. And 16 plus 3 is 19. I'm just going to put 19 over there for now. Okay. I'm going to come back to the start and do the other path. B takes 9 minutes. D takes 11. So 9 plus 11. And we get 20. Now I'm going to write 20 in there because it's the longest. It was longer than 19. Okay. So I hope you guys remember that. So if there's two numbers that end up in a position on the network graph, we take the longest one. Okay. Now, back scanning is when we go the other way. I'm just going to change colors, and this is what we're going to utilize this bottom of the house for. Firstly, the end numbers are always the same. Okay, so we're going to start with 20. But this time we're going to work back. I'm going to go along this top path for now. 20 take away 3 is 17. 17 take away 4 is 13. 13 take away 12 is 1. I'm just going to put that to the side. If I go down this path, because it will be the critical path, because it was the longest one, the numbers will end up being the same, or they should be. 20 take away 11 is 9. 9 take away 9 is 0. So our two options are 0 and 1, and we always take the lower when we're back scanning. So forward scanning, we take the higher, back scanning, we take lower, and what we end up with is a network graph that looks like this. Now, I really want you to think about this top line here, just this little bit here. Now, this project along the top takes 19 minutes. The project part along the bottom takes 20 minutes. What that means is that there is a float time along the top path of 1. So the earliest that A can finish is 12. Starts right on 0, it takes 12 minutes, so the earliest that it can finish is 12. But what's the latest it can finish without actually delaying the project? Well, the latest it can finish is 13. Because we've got a minute to give. So what we will say in this case is that there is a float time of 1. If I have a look at this path here, B takes 9 minutes, but what's the latest it can finish and not delay the project? Well, because it's the critical path, it's actually got to finish on time. If this, let's say that took 2 minutes longer than it was expected to, well then this one's going to take 11, which means we're going to end up taking 22. So the critical path, the delay is actually absolutely felt. There is no float time. However, along the top one, there is. So how do we actually calculate this? Okay, there is a process. So let's have a look at it. What we do is we need to set up a table. Now all I've got here is I've got all of the nodes or the activities. It's actually the activities, not the nodes. So the activities are the edges. And we've got estimated start, earliest start time, latest finish time, and the float time. So how long does activity A take? It's expected to take 12 minutes. What's the earliest it can start? Well, the earliest it can start is here. So what's the earliest it can start? It can start at 0. What's the latest it can finish? 13. Now, I've put up here, this was the formula that I had on before, latest finish time, which is this one, take away earliest start time, take away activity time, and I might just undo these lines, and we get 1, which is exactly what we actually spoke about just before. So A can be delayed by 1 minute and not affect the project. Okay, let's look at B though. The activity takes 9. The earliest it can start is 0 because it's starting on the start project. The latest it can finish is the end of the line, 9. There is no float time. Okay, let's build C up. I might just change colors to make it clear. How long does C take? Well, it's 4 minutes. What's the earliest it can start? Well, if A runs on schedule, it'll be finished in 12 minutes. Okay, so the earliest it can start is 12. What's the latest it can finish? Well, it can finish at 17 because it's not going to delay the project. So the latest it can finish is 17. Okay. Now, effectively then, it's this minus this minus this. Okay. So if I move backwards, again, 1. D, how long does the activity take? 11. What's the earliest it can start? Well, if B runs to schedule, it'll be finished in 9. What's the latest it can finish? 20. That, take away that, take away that, and guess what? We're going to end up with 0. And finally, E, earliest it can, activity time is 3. Earliest it can start, 16. Latest it can finish, 20. That, take away that, take away that. And we end up with 1. And that's it. That's it for this particular sort of task, okay? So we're trying to determine the float times for each activity. So we're going to move on to another example. And actually, I think you should hit pause and have a go at doing this one before I actually do it. So I reckon hit pause. I strongly suggest that you start making your houses. Hit pause and then hit play later, and you can then watch to see how you went. Okay, so let's fill this in. Remember, we start at 0 on both. Forward scanning is on the top. So 3. This one could be 10. We're not sure yet. Oh, I missed doing a house in the middle. It's a bit tricky here. Okay. This one will be 6 plus 2, so it could be 8. Not sure. But, well, it won't be 8 because 10 is more, but we'll go down this way at the bottom now. Earliest to finish is 4. 3 could finish at 7. Plus 6 is 13. Okay, so what's the highest number out of all of these? 13 goes there, and 13 goes there. Okay. It also indicates that this bottom path is our critical path. So I'll mark that as well while I'm at it. Working backwards, I'm going to go along 13 take away 7 is 6. I've got the wrong colour. Is 6. 6 take away 3 is 3, but it will end up being 0, so I'll leave that. I'm coming across the middle. 13 take away 2 is 11. 11 take away 6 is 5, but 0 will be lower. And this should be exactly the same. Now, the critical path, the numbers should always be the same. 7 take away 3, 4. Okay, so there we go. I've set up this particular one. Now, there's a couple of slides there that I actually don't need to use because I filled it in already. So I'm going to just jump down to this one, which is just the summary. So just look at this top bit here. I've just copied and pasted across. And I've sort of half filled in. I sort of put in all the activities as well. So A takes 3 minutes, and I've put the 3 minutes in there. Okay. So I'm looking at A as which is this one right up here, the whole thing. What's the earliest it can start? Well, the earliest it can start is 0. It can start straight away. What's the latest it can finish? It can finish at 6. Now, again, remember I just move along. This minus this minus this. 6 take away 0. Take away 3 is that we're going to end up with a float time of 3. Okay. B. Now, B is on the critical path. That should be a hint that there probably isn't going to be a float time. The earliest it can start is 0. The latest it can finish is 4. 4 take away 0, take away 4. We'll end up with 0. If I do C now, which is here, what's the earliest that it can start? Well, if A runs to schedule, the earliest C can start is 3. What's the latest it can finish? Finish at 13. 13 take away 3, which is 10 take away 7, we end up with 3. Where's D on here? D's across the middle. Earliest it can start, well, it's one of the ones that can start at the start. The latest it can finish is 11, which is this number in the box. 11 take away 0, take away 6 is 5. E is this guy here. I realise it's getting messy. The earliest it can start is 6. The latest it can finish is 13. 13 take away 6 is 7. Take away 2 is 5. F is this task here. The earliest it can start is 4. The latest it can finish is 7. 7 take away 4, take away 3 is 0. Now remember that's on the critical path, so it is working out for us. And the last one is, what's the earliest that G can start is 7. What's the latest it can finish? 13. 13 take away 7, take away 6 is 0. So there we are for that particular one. So we can just see that the ones that are critical path have got zeros. The other ones have got a little bit of float time. So finally, we've put quite a difficult one here. It's a bigger one. Like the previous example, I think you should pause, draw this big, I reckon this one, turn your book sideways and draw it over an entire A4 sheet. So don't give yourself space to do this. Draw it out and just see if you can work out, firstly, how to enter the numbers going forward. So remember, the forward goes in the top and the backward goes in the bottom. So have a go at that particular one. Hit pause, and then come back. Okay, so completed answers here. Again, so if I just go across this way, 0 plus 3, the 3 goes in, plus 15 becomes 18, plus 3 becomes 21, plus 2 equals 23, but the other path is going to equal a different number to that. Okay. You could follow this path here, which goes 3, then plus 4, which is the 7 that's there. Come down this way. Now again, 7 plus 2 is 9, but 4 plus 6 is 10. So the higher number wins there. Okay, so just have a look at your answers compared with what's there. Okay. If we then look at back scanning, I'll do a couple and then we'll, so 25 goes in there. 25 take away 3, 22. So we've got a bit of a hint that that's the critical path there. 25, I'm going to go the other way now. 25 take away 2 will be 23. Okay, I'm going to keep coming here. 23 take away 3 is 20. If I jump back onto this path, what happens? 22 take away 4 is 18, but I've already got 20 in there. Now, when I'm going backwards, the rule needs to be that you take the lower. When going forward, you take the higher. Because actually what that will mean is that this 18 is on the critical path, even though the bit above it is not. Okay, so it comes 18. Okay? If I come across this way, 18 take away 15 becomes 3. Okay? So 3 take away 3 is 0. So we've actually stumbled upon quite early the critical path, because all these numbers, wherever they're equal, there's our critical path. Everything else should have float time. Okay? So if I then jump onto the next slide here, you see I've popped in all the answers and the critical path. Again, have a look at yours. It is, I mean, it's not terribly difficult, but it is a bit fiddly, and it's definitely one of these ones where you could make a mistake in the pressure of an exam situation. Now, I've put in the answers for this. You've got two examples that we worked through slowly before. I mean, I might just pick one here. If I look at, so here's F, okay? The earliest that F can start, earliest start time is 7. The latest finish time is 16, and the activity itself is 7. I should have put that at the front. Apologies. Activity time is 7. Now, 16 take away 7 means the float time for task F will be 2. And if I just jump here, there we go. okay? I don't think after doing all the other examples that you need me to work through each one individually, but I think you should just check those answers against yours. Again, critical path, A and D is critical path. What else is? K and N. K and N down here are also critical path, and they've got zeros, okay? Everything else has got float time. Okay, that's it. So for further work, really, it should be page 60 in the textbook, which is 17B. And the chapter's called Critical Path Analysis with Backward Scanning. And definitely you can work your way through those.